Hey, welcome. So, if you're getting into software development, you've probably had that moment. You know the one. You're staring at a massive project idea and you're just wondering, where do I even start? Well, today, we're going to unlock the mental toolkit that turns all that chaos into clean, effective code. It's called computational thinking, and it's about to become your secret weapon for solving problems.
I mean, we've all been there, right? You've got this brilliant idea, but the path to making it a real working application just looks like this impossibly tangled mess. But listen, that feeling isn't a sign that you're failing. Not at all. It's just a sign that you need a more structured way to approach the problem.
And that structured approach, that's exactly what we're digging into today. This isn't about mastering one specific programming language, by the way. It's a universal way of thinking that will let you tackle any complex challenge, in any language, with way more confidence.
So what is this thing exactly? Well, at its core, computational thinking is all about breaking down problems and then building up solutions in a really logical, step-by-step way. It's a framework built on 4 key pillars that we're about to walk through.
Okay, our first pillar is decomposition. This is basically the art of taking a giant, intimidating problem and slicing it up into smaller, much more manageable tasks. Think of it like this. You don't try to eat a whole pizza in one bite, right? And you don't build a complex application all at once either.
To see how this works, let's use a simple, familiar example. Building the game of Hangman. At first, the task, build Hangman, sounds like one big thing. But if we use decomposition, we start to see it's really just a collection of a bunch of smaller jobs.
See? This completely changes how you look at the problem. Each one of these steps becomes its own little mini problem to solve. You can focus entirely on perfecting the get a letter guess part without worrying about the check if the game has ended logic. You just solve these smaller problems one by one, and before you know it, the whole thing comes together.
And that leads us perfectly to our second pillar, pattern recognition. Now that your big problem is broken into smaller pieces, you can start looking for similarities or trends. Spotting these repeating patterns is the absolute key to writing efficient code because it lets you create reusable functions instead of just writing the same logic over and over and over again.
Let's look at this problem. You could just start adding, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, but man, that would take forever, and you'd probably make a mistake. A computational thinker looks for a shortcut. They look for a pattern.
And here's that aha moment. Instead of adding them all in a row, what if we pair up numbers from opposite ends? So, 1 plus 200 is 201. Okay, now what about 2 plus 199? That's also 201. And 3 plus 198? Yep, you guessed it, 201. Suddenly, this simple, beautiful pattern just emerges from the chaos.
So the next logical question is, okay, how many of these pairs do we actually have? Well, with 200 numbers, we're going to have half that many pairs, which gives us exactly 100. And just like that, we have all the pieces for a brilliantly simple solution.
Finding that core pattern leads us right into our third pillar, abstraction. This is all about filtering out the noise. It's about ignoring all the irrelevant details so you can focus only on what's essential to actually solve the problem.
And you know, one of the most brilliant real-world examples of abstraction is the London tube map. I mean, look at it. It is not a geographically accurate map of London, not even close. Its only purpose is to help you get from one station to another as fast as possible, and it does that by basically ignoring reality.
The real genius here is in what they left out. The exact twists and turns of the tunnels, the parks above ground, the real distances between stations, all gone. All that's left is what a traveler actually needs to know, which stations connect, what order the stops are in, and which line to take. It's a perfect solution because it ignores everything that doesn't matter for the job at hand. And that brings us to the final pillar, where everything really comes together, algorithm design. This is about creating a clear step-by-step set of instructions, like a recipe, to solve not just this one problem, but any similar problem you might face in the future.
So using that pattern we found and abstracting the core logic, we get this incredibly simple 3-step algorithm. Now, it works perfectly for summing numbers from 1 to 200, sure, but its real power is that it's reusable. You could use this exact same logic to sum numbers from 1 to 1,000,000. Now that is the heart of powerful algorithm design.
So let's put this all together. These 4 pillars aren't just some abstract theories you learn about. They actually combine to form a practical, powerful framework you can use every single day for any coding challenge that comes your way.
This is your game plan. Anytime you feel stuck, just walk through these 4 steps. Decompose the problem, recognize the patterns, abstract the essentials, and then design your algorithm. This is the mental shift from just writing lines of code to actually architecting elegant, effective solutions.
You know, when you start to adopt this mindset, problems that once seemed totally impossible start to feel more like fun puzzles. You now have the framework to think clearly, plan effectively, and build things with real confidence. So, the only question left is, what complex problem are you going to go solve first?